In question 6 part A, we're told that h of x is a cubic function. Remember, if you differentiate a cubic function, you get a quadratic function. And we're given a graph of the first derivative of h of x. So this graph represents the first derivative of the cubic, which is a quadratic. And we're asked to work out the general formula for the quadratic function. You're given the answer, but you should always pretend you haven't been given the answer. The only reason they've given it to you is so that you can do the rest of the question. What we need to focus on first, if you can identify the roots of the curve, then you can identify the factors. I can clearly see that one of the roots is x equals minus 1 and the second root is x equals 3. If x equals minus 1 is a root, then x plus 1 is a factor. If x equals 3 is a root, then x minus 3 is a factor. If I multiply the two factors by each other, I get a quadratic equation. X squared minus 2x minus 3 equals 0. However, the other thing that you have to double check is the y-intercept. There's clearly something wrong here. This is a plus x squared, which would be a u-shaped curve. So what we have here does not correspond to the actual curve, because there's an infinite number of different quadratic curves that cross the x-axis at minus 1 and 3. This is simply one example of a curve that crosses at minus 1 and 3, but it's not the one we're looking for. So what we should hone in on is the last value. The minus 3 here represents the y-intercept. Clearly our y-intercept is not minus 3. Our y-intercept is plus 6. So you just have to ask yourself, what do I need to multiply this term by so that it's a plus 6? Well, minus 3 multiplied by minus 2 will give me plus 6. So in order to make sure that the y-intercept is correct, we multiply that by minus 2. If we're going to multiply the last term by minus 2, we have to multiply every term by minus 2. So we're going to multiply the entire equation by minus 2. The left hand side by minus 2, I get minus 2x squared plus 4x plus 6. If I multiply the right hand side by minus 2, it stays as a 0. And clearly this corresponds to what we were given in the exam question, so that's our final answer. Now in part B, you just have to be careful with the language. We're asked to find the maximum value of the slope of h of x. If we were asked to get the maximum value of h of x, then it would just be a normal finding a maximum point question. We're looking for the maximum of the slope. Remember, in differentiation, the first derivative represents the slope. So this is the slope, what we worked out in part A, minus 2x squared plus 4x plus 6. Now we're being asked to find the maximum point of this. So don't get confused with your derivatives here. This is what we're trying to find, the maximum of this. In any finding the maximum point question you've ever done, the first thing you do is differentiate and let it equal to 0. So to find the maximum of this, I need to get the derivative. And because we're already on the first derivative, this is actually the second derivative of h of x. However, it's the first derivative of what we're trying to find the maximum of. I want the maximum of this. So its first derivative will be minus 4x plus 4. And remember, to find your maximum point, you simply let the first derivative equal to 0. Remember, the first derivative of what we're looking for is minus 4x plus 4. So that means to identify the turning point, I let minus 4x plus 4 equal to 0. And now it's straightforward enough. I'll subtract 4 from both sides, and if I divide both sides by minus 4, I end up with x is equal to 1. So that tells me that when x is equal to 1, that's when I identify the maximum of the slope. But obviously what I want to do is find the actual maximum value, which is the y value. So we take our x equals 1 and we sub it in up here. So if I sub in x equals 1, I simply get minus 2 times 1 squared plus 4 times 1 plus 6. And if you plug that into your calculator, you get 8. Now you'll notice here that I haven't proven that it's a maximum rather than a minimum. You don't need to prove, when your original is a quadratic, you don't need to prove whether it's a maximum or a minimum. This is a minus x squared. And obviously a minus x squared is an n-shaped curve. You can see it on the diagram that's given in the question. You can't have a minimum value. If a curve is that shape, there's no such thing as the minimum value. There's only one turning point. The turning point has to be a maximum turning point. So the turning point, and you can actually see it easily enough from your diagram, is the point 1, 8. And we're asked to get the maximum value. The maximum value, the answer in this case, is 8. In the final part of this question, we're asked to identify the formula for h of x, given that the point 0 minus 2 lies on the curve. You should remember that we've been dealing with the first derivative in part A and part B. We have the first derivative and we want the original function. So obviously we need to do the opposite of differentiation. If I integrate the first derivative, that will give me the original function. So when we integrate, we get minus 2x cubed over 3 plus 4x squared over 2 plus 6x plus c. And the problem now is that I don't know what the c is, the constant at the end. For when working out just from the first derivative, there's not enough information there to know what the constant at the end was or what the y-intercept is. However, that's why they've given me the other piece of information. I know that the point 0 minus 2 lies on the curve. At the moment, the curve is h of x equals this. I just want to point that out because remember that h of x is equivalent, we can think of that as our y. Y is equal to all of this. I can sub in x equals 0 and y equals minus 2, and I did that on this line. You'll notice that the only unknown we have is c, so we have one equation and one unknown, we can solve for c. It's easy enough because everything else just becomes 0. There's x's in every other term, so everything just becomes a 0, and you end up with c is equal to minus 2. So my final answer, where I got this line, basically I'm just copying what I have here. It's minus 2x cubed over 3, 4x squared over 2 is the same as 2x squared, plus 6x, and I now know that c is actually minus 2. That's the original function which we've worked out from the first derivative.